A coordinate proof is different from a regular proof because instead of using a two-column statement reason chart and instead of proving things using definitions and logic and theorems, with a coordinate geometry proof, we prove things with formulas, with calculations, and with numbers. So our format, instead of making a statement reason chart, is going to be to write down our formula. It's very important in case on a test or the Regents exam you remember a formula incorrectly. It's always good to write the formula that you remember down. So just in case there's a mistake in the formula, you don't lose all the points for the question. Show all your plugging in and work for the same reason. You don't want to lose all the points for the question. Also, if you don't show work, you don't get the full credit. And then to write a concluding statement explaining what your work proves. You might have a bunch of numbers on your paper, but the important part is what did you show with these numbers, right? And you actually don't get full credit on the Regents exam and also on the test that you're going to take on this topic in your geometry class if you're missing your concluding statement. So let's start off with triangles and then we'll work our way into different quadrilaterals. So here in this example, we have triangle RST, and I'm going to take a second and I'm going to graph the triangle. And already I can see that this is going to be a coordinate geometry question because we are given coordinates. They do give us a coordinate grid, which is always optional, but I do recommend graphing so you could see better what you're working with. So there's point R, point S, and then finally point T. And then if I continue reading the question, it says prove. So since this is asking me to prove something, but we do have coordinates, we do have numbers, we do have a grid, that tells me it's going to be a coordinate geometry proof. So I'm not going to make a statement and reason chart. When I look at what the proof statement is asking me for, I'm going to think about what formulas I can use in order to prove what they're asking me to prove. And what I need to prove is that RST is a right triangle. In order to show that it's a right triangle, I do need to show that it has a right angle. And it does appear, I'll have to prove it, but it does appear the right angle is going to be located over here by angle S. And I know that in order to have a right angle, right angles are created by perpendicular lines. So if I can show that the two lines forming the right angle are perpendicular, RS and ST, if I could show that they are perpendicular, then I'll know that there for sure is a right angle there, and I'll know that I do have a right triangle. So I'm thinking about what formula I can use to show perpendicular lines, and I'm thinking of slope. Slope is what comes to my mind. So I'm going to write over here that I'm going to find the slope of RS. Oops, sorry, my paper's moving everywhere. And I'm going to find the slope of ST. And I'm going to see if those two line segments are in fact perpendicular. My slope formula is y2 minus y1 over x2 minus x1. Or you can use the grid and use rise over run, but I'm going to just plug into slope formula really quickly using points R and S. So I'm just going to label x1, x2, y1, y2. I like to do that so that way I don't get confused. And I have y2 minus y1, x2 minus x1. And I would recommend that you do pause the video and try to do the calculations yourself because it's really important that you do know how to plug into the formulas. So I would highly recommend that you do pause the video and try to get the answer to the calculations yourself. So we have -1 minus 7, and that is -8. And I have 3 minus -1, which is 4. I'm sorry, that's a really bad looking 4. And that is -2. And then the slope of ST. So now I'm going to be using points S and T. So I'll just erase that so I don't get confused. X1, X2, Y1, Y2. I love to do that. And I already wrote my formula down, so I'm not going to write my formula again. I'm just going to plug in 2 minus -1 over 9 minus 3. And now let's look at the slopes and see if we can find a relationship between them. It might be easier to see the relationship if you put this one over 1, But notice how one's a negative and one's a positive, so they're opposite signs. And notice how one is the other one flipped over. We have 2 over 1 and then 1 over 2. It's the reciprocal flipped over. So they have an opposite reciprocal relationship or a negative reciprocal relationship, and that indicates that we do have perpendicular lines. Perpendicular lines have opposite reciprocal slopes. So I'm just going to end with a concluding statement here. That's the format of a coordinate geometry proof. Since RS and ST have opposite reciprocal slopes, they are perpendicular, so they form a right angle, making triangle RST a right triangle. And there we have it. We have our formula, our work that shows our plugging in, and then we have our concluding statement explaining what our calculation showed. And that's all there is to a coordinate geometry proof. We're going to see some examples of when it gets a little bit more in depth, where we have to prove some more stuff and use some more formulas instead of just proving one thing. But generally, coordinate geometry proofs are a 6-point or 4-point question on the Regents exam. So if you know how to plug into your formulas, it's one that you can guarantee that you can get right. And it's worth a lot of points usually, which is great. Okay. Over here, I have another one about a triangle. I'm going to just graph this really quickly so that way you could see it. And once again, using the grids is always optional, but highly recommend that you do use the grid in order to avoid any mistakes that don't need to be made. If it's there, why not use it? Prove that ABC is an isosceles triangle, but not an equilateral triangle. So in order to know what I need to do here, I need to know what an isosceles triangle is and what an equilateral triangle is. So an isosceles triangle is a triangle that has 2 equal sides or 2 congruent sides, whereas an equilateral triangle has 3 equal sides. All the sides are congruent in an equilateral triangle. So if I'm showing that 2 sides are equal but not the third, what I have to do is I have to find the length of all 3 of the sides and show that 2 of the sides are the same, but 1 of the sides is different. So I'm going to write down my plan here. I'm going to find the length of AC. That's one side of the triangle. I'm going to find the length of CB. That's another side of the triangle. And I'm going to find the length of AB, the last side of the triangle. And I'm going to show that 2 of these lengths are the same, but 1 is different, so that it'll be isosceles but not equilateral. In order to find lengths, you could either make right triangles with all the sides and use Pythagorean theorem, or you can use the distance formula. And for me personally, I like using the distance formula better, so I'm going to do that. I'm going to write down my distance formula. And always write it down just in case you remember it incorrectly. Always write it down so that way you don't lose all the points if you made a mistake in the formula. And now I'm going to show all of my plugging in, and I highly recommend that you pause the video and you try to do the calculations yourself to make sure that you are able to do it, because that's the most important part of this, being able to plug into the formulas. So for AC, I need to use A and C. So I'm going to do the same thing I did with the slope formula before, and I'm just going to label my points. And once again, I really like to do that. And if you're typing into the calculator, do not type the radical into the calculator. Just type in what's underneath the radical, but remember to bring the radical down. It'll save you a lot of confusion. Okay, so I got radical 26. Now I'm going to find the length of CB. And I'm not going to rewrite the formula for this one. I'm going to switch my color to purple because I have my formula up there. I'm just going to plug in. But I'll reset this over here, the labeling, so that way we don't get confused. And then finally, we have one more to go. And there we have it. We have that two of the sides are the same and one isn't. And the good part of proofs, all proofs, is that if they tell you to prove something, it's going to be true. So if I had done these distance formulas and I didn't find that two of the sides were the same and one was different, then I would need to go back and check my work, because I know that since I didn't get what I'm trying to prove, that my answer is wrong and I made a mistake somewhere. So luckily, I found that two sides are the same and one is different, so I'm all good to go. I can just write my concluding statement. Let me try to write it somewhere where I have some space. Since two sides are equal, and I'll put in parentheses AC and AB, but not all sides are equal, triangle ABC is isosceles but not equilateral. And be careful for this question, you did have to find the length of all three sides, because it did ask you to show that it's not equilateral. If it didn't ask you to show it's not equilateral, if it just said show that it's isosceles, then it would be fine to just do the two sides that are equal and you don't have to do the third one. But if it says prove it's also not equilateral, you have to show that the third side is not the same, because else how would you know that? For the next one over here, we actually have a quadrilateral. I'm going to take a second and I'm going to graph it. And especially for quadrilaterals, you should always, always, always graph, because people often mix up the sides and the diagonals. I want to make sure I don't mess up my graphing. There we go. Now we can clearly see what the sides are and what the diagonals are. So my first part of my proof is to prove that the quadrilateral is a parallelogram. And there's multiple different ways I can do that. But for me, I want to pick the way that's going to make my life in part 2 the easiest. So in part 2, it says to prove that JKLM is not a rhombus. And the first thing that's coming to my mind is that a rhombus is equilateral. So if I can show that it's not equilateral, that consecutive sides are not congruent, then I'll have shown that my parallelogram is not also a rhombus. So I'm going to find the side lengths. So I'm going to use that for 1 and 2. I'm going to show it's a parallelogram by showing that opposite sides are congruent. And then that will accomplish my goal of also proving that it's not a rhombus, and I'll only have to use one formula, which is what I like to do if I can. So I'm going to use distance formula. So I'm going to put a 1 for part 1. So I'm going to be proving that JKLM is a parallelogram. To be a parallelogram, one property that I can prove is that the opposite sides are congruent. So that would be JM and KL would be the same length, and JK and ML would have the same length. So that's what I'm going to show. So I'm going to start with JM. Okay, and I'm going to write down my distance formula just like I did in the previous example. And I'll only do it the first time. Okay, and I'm going to be using points J and M. Once again, you should definitely pause the video and make sure that you're able to plug in. Sorry, that looks so gross there. There we go. And the nice thing is, since I know this is going to end up being a parallelogram, when I find the opposite side to JM, which is KL, which I'm going to do next, it should have the same length because I'm proving it's a parallelogram. And if it doesn't end up having the same length, then that means I did something wrong and I can go back and check my work. And look at that. Ended up having the same length. So I showed one pair of opposite sides is congruent, J, M, and KL. I do have to also show the other pair of opposite sides. So I do also have to show JK and ML. So I'll do that in a different color. And I know this seems like a lot of work, but it's going to make our life in part 2 a lot easier, which is why I'm doing all this work. Now for ML, and that's our last side. And look at that. That worked out super nicely. So now I need to write a concluding statement that explains what I just showed in part 1. So I'm going to write that down over here. I'll continue part 1 over here. Since both pairs of opposite sides are congruent, JKLM is a parallelogram. And now I need to explain why it's also not a rhombus. When I found the side lengths, the opposite sides were congruent, but all the sides were not congruent. It was not equilateral. So I'm going to put that down over here. Since JKLM is not equilateral, it is not a rhombus. And there we go. We're finished with this one. Let's do another one. This one's going to be a little bit even more involved than the last one. So Jim is experimenting with a new drawing program on his computer. He created quadrilateral team, and it gives us the coordinates. So I'm going to put down the coordinates on my paper. Always a good idea to graph so that you don't end up mixing up sides and diagonals. Jim believes that he has created a rhombus but not a square. Prove that Jim is correct. So the very first thing is that team right now is just a quadrilateral. That's just a four-sided shape. So before it could be this rhombus that Jim believes it is, it first has to be a parallelogram. Because in order to be a rhombus, it does have to be a parallelogram. So my first step is I need to prove that I have a parallelogram. And then after that, I do need to prove that I have a rhombus. I'm going to do a little different route than last time, even though it's kind of the same where I have to prove parallelogram and then rhombus. I also have an added component here where I have to prove it's not a square. So it doesn't matter if you use distance formula or slope formula. You're going to have to use two formulas here regardless. I'm going to take the slope formula route this time, and you'll see why in a second. So I'm going to show instead of opposite sides are congruent, like I did in the previous example with distance formula, I'm instead going to use slope formula, and I'm going to show opposite sides are parallel to prove it's a parallelogram. Should be a little bit faster for me as well. So I'm going to put that over here. I'm going to label it as 1. My part 1 is to prove I have a parallelogram. So I just want to keep that in mind. So I'm going to find the slopes. So let me find the slope of Tm. And I'm going to just write down the formula I'm using. You can also use rise over run if you want to. And I'm using T and M. Okay, and when I find the slope of the opposite side EA, it should end up being the same thing. I'm not going to write down the formula again. I have it before. Great, so far so good. Now I'm going to find the slopes of the other pair of opposite sides. And they should work out to be the same as each other. So let's see what TE is. Oops, negative over a negative is a positive. There we go. And now when I find the slope of MA, it should work out to be the same as TE. So I'm expecting it to be 7 over 3. Let's see if it actually is or if I made a mistake. And it works out to be the same. So I'm going to write down how I know it's a parallelogram. Since both pairs of opposite sides are parallel, team is a parallelogram. And parallelogram is the only quadrilateral that has a symbol. Now, I need to show that it's not that it is a rhombus. Sorry, it is a rhombus. So I can take any two sides and find the lengths and show that consecutive sides or adjacent sides are congruent. And that means that all the sides are equal and means it's a rhombus. You don't have to do all 4 sides. You can take any 2 next to each other. So for example, I could take TM and MA, find the lengths, and show that they're the same. But I'm just going to do all slopes. So I'm going to do the slopes of the diagonals. Because remember, rhombuses, they do have perpendicular diagonals. So if the diagonals are perpendicular, it's a rhombus. So I'm going to find the slope of TA. I just want to go completely slopes this time. And the slope of TA is -1. So I should expect the opposite reciprocal for ME. And look at that. We have -1 over 1 and 1 over 1, opposite reciprocals. Since TA and ME have opposite reciprocal slopes, they are perpendicular. A parallelogram with, oops, my pen's being weird. A parallelogram with perpendicular diagonals is a rhombus. And then finally, let's show that it's not a square. In order to be a square, it needs to be both a rhombus and a rectangle. In order to be a rectangle, one property that would make it a rectangle is right angles in the corner angles. But when we found the slope of all the sides, when we were proving it's a parallelogram, there were no opposite reciprocal slopes. 3 over 7 and 7 over 3, those are not opposite reciprocals. They're reciprocals, but they're not opposite signs. So they're not opposite reciprocal slopes. So there's no perpendicular sides, so there's no right angles, so this can't be a rectangle. I'm gonna write that. Since no sides of team have opposite reciprocal slopes, there are no perpendicular sides, so there are no right angles. That means team is not a rectangle. And then I'm going to put, since team is not both a rhombus and a rectangle, team is not a square. That one was a lot of work, but there we go. We proved that Jim was correct. It's a rhombus, but it's not a square because it's not also a rectangle, so it's not also a square.